Hey, what's up everybody? This is Bart coming to you from TST Industries in Florida. I have a special episode of TST Garage for you today. Finally got our hands on a Kawasaki Z400 and we'll be showing you how to install our new Mech-GTR signals on that bike. What's so special about these? Well, check this out. This is a flush pod style signal. It's not exactly a flush mount like these signals you see that we've been selling for bikes for a number of years now. It's not exactly a pod signal. It doesn't have a stock. We do have several different versions of a pod signal already available. Now we came out with these flush pods. What does that really mean? They sit flush against the mounting surface, but they protrude like a pod and they fire forward and within the specified angle of where they're supposed to fill in light. These are really cool. They have been designed to optimize aerodynamics and also optics. We do have one single very high power LED firing through a lens array that really takes that light and spreads it around and makes it full right in front and to the side of the bike. Later we'll show you these things fired up and you'll witness just how bright these really are. The other really cool aspect that I feel is a really great designed in spec is how these mount to the bike. I'll show you on a different shroud from a different bike, but you basically pass them through the shroud, and from the other side, you pass onto the wires this fastening ring that has springy teeth on it, and it just ratchets onto the signal body. It doesn't require turning any screws or anything. It just zips right on, and then you preload the springy teeth, and that prevents vibration. In case your bike falls in between the ratcheting teeth that we have, the thickness of your mounting surface is slightly thinner than optimal. We do provide these rubber grommets that go around the body of the signal just below the mounting surface on the ratchet side, and that helps to increase the friction and prevent this thing from moving around. If you need to ever slip these off, you just pry back on the ratcheting mechanism and work it off. It's pretty simple. Another feature that I think is really great on these signals is that you can outfit them with optional running light modules. You would need to fold this wire over and then get it around the main wire of the signal and just slide it in there until the teeth grip. They also ratchet in place. All right, now that we've inserted a running light module in this, and now we have the capability of a running light, we have to do something about actually wiring it in. So we have 3 wires. One is ground, one is for signaling, and one is for running light. On these bikes, you only have a 2-wire plug that connects to the OEM signals. So that means you will have signaling and ground. Using the provided harness converters, we will be able to plug in the signaling circuit and also have the ground plugged in. However, a running light circuit requires a different connection. So, like I said, these are optional. For this particular bike, they require a separate connection kit. These come with the connection kit for this particular bike. We outfit you guys with the appropriate wiring and connectors to be able to make use of a fused and switched positive 12 lead that is just behind this headlight. This is optional. I will show you how to wire it in, but you will ultimately have to decide if you want to go with just the signal kit, which is a little bit less expensive, or if you're willing to take the steps to connect this kit in to have a running light. One thing I didn't mention yet is that these running light modules exist in several different colors. For this bike, we'll be using hyper white. We do have amber, we do have lemon yellow, blue, pink, a couple different colors. Check it out on our website, tstindustries.com. You'll see photos of all those different lights lit up, and you can make your selection there. Anyway, I'm almost done talking. We'll get to wrenching really soon. I just want to mention that whenever you go from the incandescent light bulbs that typically come in OEM signals to LED type signals, you will draw much less current from your signaling system and it will start hyper flashing. It will flash much faster than the 85 cycle per minute flash rate that is set by the manufacturer because you're drawing less current. So to combat that, you can replace the OEM relay by plugging in one of our Gen 2F relays. The location for that relay is just under this shroud. We do have a separate video showing you how to install this component, so you can check that out on our website or on our YouTube channel. Now I'm really done and I'm chomping at the bit to get on the bike and start wrenching, so let's go. First step will include removing these 4 fasteners using a 4mm Allen, and that will enable us to take off this little tiny windscreen. Now we have access over here. We'll be removing this, and this 10mm head screw. Make sure you retain the washers where the washers exist, and remember the sequence and the location for the different screws. All right, now I'm going to switch back to the 4mm Allen. Remove these screws along with their washers. Now we'll have to switch to a 5mm Allen and get deep in there. When these screws come out, the headlight assembly with the shroud and all these plastic components and the signals is free to move about 2 pegs that sit inside rubber grommets down on the bottom. So now we'll just remove the signal plugs from their mating harness plugs. Here's a gray one, on the side should be black. I just like to use a tiny flathead screwdriver to pry the locking mechanism. It makes it much simpler. Now we'll also have to remove the main plug here. It's a 4-conductor Sumitomo plug. Also has a locking feature that can be pried up with a little screwdriver. Once we've done that, we can undo this cable management clip, and that will permit us to remove this whole assembly. We'll take it to the table and I'll show you guys how to get everything connected there. All right, the next couple steps here will take place on the table. It is much easier to work on a flat surface with these components. Under here, you'll notice there is a screw that holds the back plate of the signaling hold mechanism to the back of the shroud. We'll need to remove that using a Phillips screwdriver. Once the screw is out, we can pry out this component, and then there's an additional steel plate within the rubber boot of this signal lamp. Once that is pried out and taken out, and this wire is unrouted from the cable management geometry here, we can grasp and turn and pull, and that signal just comes out. I'll just repeat this. I'll repeat these steps on the left side of the assembly. Now that's out. Slide it to the side, and we will begin mounting our new Mech-GTR signals. These are not side specific. One or the other can go in either side. We will feed our wire through first. Seat these deep in the well there. Get our ratcheting hold down clip around the wires. Make sure the springy teeth go on first, and that way you can pressurize them against the back of the shroud here. What I like to do is press down on this ratcheting mechanism until I preload the teeth that contact the shroud from within. And once I've done that, give it a test to make sure it doesn't move around. Now, on this particular bike, these are pretty solid on here. They will not require the extra grommets that we send with these signals. So that'll be pretty much it. If you are installing just a signaling system without the running light system, then you will repeat this procedure on this side and then just follow the steps necessary for the connection on the bike using our plug-and-play harness converters. I will be demonstrating the installation where we actually add these in. You will just need to determine if those steps are acceptable for you, if you want to go through the difficulty of installing all of that equipment, or if just signaling is enough for you. So I'll leave that up to you guys, but I'll show you the longer and more difficult but much cooler end result. As you saw here, I bent this wire over and under through the slot. The wire from the main signaling function of the signal gets passed through like that as well. We snap this in, and now we have to connect it. What I like to do is wrap this wire one way, wrap this wire the other way. This gives a little bit more strain relief on this connection here and manages it a little bit better. And now this, just like before, gets passed through, and we insert that ratchet ring, get it on the signal body, ratchet it down, preload it, and then that side is ready to be connected. Okay. So I have a running light on this side. I don't yet have a running light on this side because I didn't demonstrate that. I will quickly just get this up to speed with where we are on the other side. All right, so now we have 3 bullet connectors on each side of our signaling system. The bike is equipped with the female part of this plug. So we will be using our plug-and-play converters that come with the Kawasaki specific signal kit and terminate in female bullet connectors that accept these, and Kawasaki specific male, just like on the OEM setup. Now, what do we do about our color configuration here? Blue from our signals is the running light. This will not be used with these. That will be plugged in via the extra kit. We'll connect the black on the harness converter to the red on the signal, and then brown on the signal to the yellow. As you can see here, we have these insulating sleeves, but they do move around. If you just leave them unlocked like this, they will have the ability to slip off, and then they could touch ground and short, and you'll blow a fuse. So for the purpose of making sure that we don't encounter that situation, we will lock these in place with electrical tape, and we already have ample insulation via the use of these sleeves. We just lock them in place using electrical tape so they don't move around. Okay, we're good to go for signaling on this side. I'm going to repeat the steps here. All right, so we're good for plug and play signaling here. Now we need to figure out what to do about attaching our running light components to a proper switched and fused connection. Here in this main plug, we have a blue wire that we can actually tap into. And for that purpose, we include 2 of these nice connectors that remain reusable, and you don't need any special tools to install them, uninstall them, or anything down the line. So to make for a really nice connection, very easy to use, what we'll do is get them pre-configured here on this blue wire. We'll spin the top portion off the bottom. The bottom is the larger screwed component that passes around the wire, and our top has a piercing element that protrudes through, and as you screw it on, it will pierce the insulation of the wire and make your connection. We'll do the same thing right next to the first one we just installed. Now we have the ability to attach and connect two wires to this blue wire. Blue, blue, and blue. It just so happens that it worked out that way. It's nice and easy here. So what we'll do is stretch out this connection kit wire. We provide one single wire that is meant to be snipped into two pieces and taken down to size afterwards. On this particular bike, I will just slice it in half and start with one. Get it connected to this blue wire here. This is just a simple bullet female to male connection. Again, you want to make sure that this sleeve is over the actual conductors. This will have a constant positive 12 voltage through there. You don't want that to short to ground and end up blowing up a fuse, and also taking out your running light circuit from the bike. Just get all these taped together just so that my wire management later is going to be simpler. All right, that is nice and neat. And now I'll just have to make sure that I can pass my wires through my routing management guide here and distribute my bulk in a way that it doesn't obstruct anything else on this bike. It also doesn't cause any stress to the wires going into the actual signal. So I think we'll have to go back and forth here a couple times like this. We'll try to make use of whatever routing guides we have for cable management on the actual bike here. We do have some left over there. If we don't have enough to manage this bulk, what we'll do is just put two zip ties in here, and that'll be that. So I think I like the length that I created just by slicing this thing in half. What I'm going to do is just get it connected now to one of these connectors that I've installed previously. I'll strip off some of this wire. I want to expose about 3/16 of an inch, and then we'll take one of these small end caps off. They do unscrew. It's pretty easy to let it go and lose it, so be careful. We'll pass the stripped end through until it protrudes, and then get it seated around the element that connects it, and then screw it down. As you screw down to the bottom, you make the connection and prevent the wire from coming out. Just one note here, make sure that there is no uninsulated wire showing here. If there is, you have a constant positive 12 volt voltage present there, and if it touches ground, you'll short, blow a fuse. Now I'll just repeat the procedure on this side. All right, same thing, figure out the wire bulk, Everything still fits within our parameters here. So let's strip off this wire and connect it in the same way. All right, now I believe we are properly connected. We do have a hairy mess going on here. We will take care of that when we get this thing back onto the bike and see how we could possibly route all of these wires. One thing I forgot to do here is route it through this cable management. I don't know if that's absolutely necessary, but I like the fact that the manufacturer thought of cable management here in this section. So I will actually redo this and make sure that we have that through there, not causing strain to our wires. All right, let's get this installed on the bike, test the actual light functions. If everything goes good, then we'll fix the wire bulk situation, get this all nice and neat, buttoned up, and I'll show you guys how this works all put together. Now we'll need to place these grommets back on their receiving pegs here. That will hold our headlight up here. If you do let it go without any other support, it will come off, so make sure you don't just let it go. I will first plug in the main headlight plug just to make sure that our connections are not inhibiting anything else. And that actually looks pretty good here. They just come up and over. Now I'm going to take the right signal and plug it into the gray OEM signal plug. And then this left one here will go in black. And now we can fire this thing up and see if we've made the connections properly. As you can see, we have running light, signal, signal. This clearly demonstrates the hyper flash. Anytime you move away from the incandescent signals, the OEM signals, you'll flash faster. You'll need to change that relay unless this doesn't bother you. It won't damage any of the electronic components in there. We get that question a lot. It doesn't matter to the light if it's flashing faster or not, but OEM set these things at 85 cycles per minute. So we like to give you guys the ability to slow it down in case you want to do that. Like I said before, we'll plug it in first, make sure it works, and then figure out the wire bulk. So that's what I'll be doing now. I'll get my wires into my cable guide. I'll include my blue wires in there as well. And once you clip that together, you have sort of a self-supporting assembly. I wouldn't trust this to too much load, but we can leave it hanging for now. So now I'll just grab some zip ties and make this into less of a hairy mess. Make it nice and neat, and then we can move on. There's not really a lot of guidance I could give you guys during this step other than to tell you that what you want to do is make sure that there's enough slack so nothing gets tugged on after installation, and also making sure that you don't put any force on these circuit boards that are in line on the wiring to your main signals. Those are NOT gates that are responsible for shutting down the running light while your signaling circuit is working. If you clamp over that, you will likely damage something and make it not work. So you want to make sure wherever you put zip ties or any sort of cable management system you've chosen to use, it is not directly over these circuit board areas. Clip these things off, get it ready for reassembly here. I'm going to rotate this back gently, make sure to route all the remaining wires that are hanging out around all the geometry that may snag, and looking pretty good here. Once you find a location for everything that doesn't cause any strain on the wires, nothing is clamped down, you can begin the reassembly of these 5mm Allen head screws. Now we can just continue in the reverse order of disassembly, and we will be done real soon here. All right, test it one more time. The entire system seems to be working right. You do have a hyperflash symptom. We'll cure that in a separate video when we'll show you guys how to install the LED flasher relay under here. For now, this will be it for me. This installation is complete. Please check out tstindustries.com where you'll find these signals, other signals, integrated taillights, fender eliminators. We have a whole host of parts for this bike. Hope to see you there. Take care.